Okay, so we're going to build a 6-card rig, 6 570s 4GB Sapphire Pulses. One of them is an ITX, but they practically are exactly the same in terms of hash rate. We're going to mine Ethereum from these, but yeah, in terms of hash rate, it's pretty much exactly the same as the standard 570 pulses. The only difference being obviously there's only one fan and the car is considerably smaller. I actually think they're slightly better cars because they draw slightly less power but actually get the same, sometimes occasionally a bit higher hash rates as the pulses, as the standard pulses that is. So I've just built the frame, gone ahead and built that. This was £75 on eBay. I did buy a £35 one for the last rig, but it was junk. This seems a lot sturdier. I'll put the links to everything I've got in the description, but I've just got a cheap £75 motherboard. One that just has 6 PCIe ports, obviously 4 1X and 2 16X. I think it might be 5 1X, 1 16X. But anyway, we're using risers, so that's not a problem. Standard DDR4 RAM. This is just Crucial RAM. UDIM 2400 megahertz. This is a Pentium processor. Again, your processor and RAM doesn't really matter when you're mining. So if you're mining Ethereum, it doesn't matter anyway. If you were mining on your CPU, it'd be a different story, but this isn't CPU mining. For density purposes, some people, what they like to do is they like to build tri-miners that mine on hard drive as well as CPU and graphics cards. The reason they do this is because they just get more density out the entire system. If you think about, you've got an outlay cost of your motherboard, your RAM, processor, and whatever your OS is going to run on, whether that be hard drive, SSD, or pen drive. Those are costs you can't make money back directly from, but you need them in order to be able to mine. The concept of a tri-miner is basically using as much of your system as you possibly can. So the hard drive space, the processor speed, that's the Pentium. It's just a LJ151. See how it focuses? Is it gonna? No, not gonna focus. But yeah, it's LJ1151 G4400. Yeah, 2 cores, just a standard Pentium. I think it was about 40 quid, something like that. That was about £35. But yeah, what I'm gonna do is I'm gonna put the motherboard on here. I've got 2 power units this time, mainly because I could have got one 1200 watt power unit. I know that's slightly overkill because we probably won't even come to 1000 watts, but I don't like to run power units to the max capacity. I don't think it's healthy for them. This is 2 650 watts power units. I think they're Pentium or gold, they might be gold. Corsairs. Yeah, modular, obviously. You're going to need that. You can cope without modular, but I don't like that. I much prefer modular power units for this kind of, well, for any rig really, it's much better. And this is a little cable that's going to allow us to sort of link the 2 power units together into one, so that when you obviously turn the motherboard on, well, the computer on via the motherboard, it sends the power signal through to both of the power units, which obviously then powers everything together. Likewise, when you're shutting it down, it just keeps everything sort of in sync. But these were about £75 a piece, these. Which isn't bad because you're effectively getting 1300 watts for about, what, 150 quid, whereas you'd be paying £210 for a 1200 watt Corsair power unit, which I have done before. They basically weren't in stock. I would have normally done that, but I thought I may as well try it out. I can't wait 4 weeks for a power unit to come, so I thought I'd give this a go. And a lot of people do it online. The other option is a server PSU, but don't know, bit fiddly I think, and they're probably better for other reasons. They're probably I don't think they're going to be as efficient as a ATX PSU, but obviously server PSUs are sort of built to just be slotted into servers, so you have to kind of get I can't remember what the term is, the name of it, but you have to get like an adapter, like a chipboard attached to the server PSU, and then you have to mess about with the cables or get specific cables to make it so that you can use it on an ATX motherboard. So yeah, I couldn't be bothered with the hassle, so I just went for 2 Corsairs. So anyway, gonna put the motherboard on here, power units, etc. Obviously seat the processor and the RAM, and then we'll go from there. So yeah, all I'm basically doing now is screwing via one of these little screws the motherboard securely to the frame. Obviously what you want to try and avoid doing is screwing these screws in too tight, because you can, I mean it's difficult to do this, but you can crack the motherboard. Again, screws that came with the rig, and out the way there, keep it in, and as it starts to get a little bit tighter, just like that, don't force it. Again, you do not want to crack your motherboard. Next thing I need to do is figure out how I'm going to seat these power units. Looking from the picture on eBay, it did look like there was 2 power units on, which was one of the reasons why I decided to get this frame. So I'm just going to get the power units out and try and seat everything on the frame before I start fiddling about with wires and things, because from experience it just makes it easy if you seat everything first. Any problems that you might have encountered with building the frame and the errors you might have made, you can correct quite quickly and easily. So yeah, let's get that sorted first. So as you can see, it looks like these power units fit nicely into here. These are considerably smaller than the HX 1200i. These are the RM650Xs. But yeah, these are considerably smaller, so yeah, and lighter as well, which is good. So I'm going to seat these on here. That way. Okay, so I've managed to screw these in, and they're nice and secure. Okay, so the next thing I'm going to have to try and do is seat this processor. So ping this up. Let's have a look. Now processors can be a bit of a pain to seat. You don't want to bend any of these little tiny pins in the board, because again they won't give you another motherboard if you bend those. It's considered damage you inflicted. If you can, try not to drop it. That's what makes it more likely to bend the pins. You always get this little black thing attached to these, and just take that off. The other thing in these is you get a little fan in this box, and they generally have thermal paste already on it, so you don't need to worry about that. Just here, see, those 3 stripes are thermal paste, so First of all, what we're going to do is just check that that's in there, which it is, all nice and snug. And then simply put that under there. Now that is quite stiff. Don't worry so much about that. It is meant to sort of be forced, the metal arm underneath. And there's no sort of clicks to let you know that you've done it right. So don't worry about that. As long as your process is seated properly, you should be absolutely fine. In terms of the fan, what you want to do is make sure that you position it to where the actual fan is going to connect into the board. So for example, on this board, the fan is here at the back. Nice little bit of room there. And then you simply just press each one of these down, like so. And that's just firmly connected in there like that. Just zoom out a bit there. There we go. And that fan will start spinning. Next thing we're going to connect up is the RAM, which again is just some cheap Crucial RAM. No need for anything too fancy. It's really not necessary. 4 gig is more than enough. I'm going to place this nearest to the processor. Like that. So there's like a little indentation at the bottom there. And it can only, it's slightly aligned from the centre so that you can only put it in the board in one particular way. Don't force it too much. Just let it click in either side. And then the 2 catches either end will hook the RAM in place. You get a nice little click. So next what I think we'll do is connect the power up from the 2 power units. So this will need the connector I mentioned before. Looks like we'll figure this one out together because I'm not quite 100% sure how this is going to work. My assumption is that we'll plug these two into either one of these, and then the connector will connect these 2 ends, and then the third part of the connector connects to the motherboard. So I'm just going to connect that up to test that theory. So you want these ends into the power unit, like so. And then this end is obviously, normally would be for the motherboard. This end's got like a 4-port coming off it, and that sort of just connects in like that. And this Type 4 on this side, just like the last one. So it looks like we've got 2 female ends, these 2, and a male end. So I assume this one goes into the motherboard, and that these 2 connect to whichever you deem. Sorry, these 2 connect to these female ends. So I've given this last power unit sort of the main power for the board. Female end's only got 2 cables because all that's doing is acting to turn this on. So if I connect this to here, all this is doing is acting to sort of short, if you like, this power unit, this second power unit. This power unit is the primary. This is just turned on to add as extra power basically. This third side is just going to connect into here. Sorry if that's a bit blurry. Ah yeah, see the clips up this way, and they've got a slight elevation there, which means that it connects this way, like so. I've got a nice little click there, and there we go. So coming back to the side of the motherboard that we used to connect the fan, if you remember, I'm going to put this cable in, and this connects to our primary power unit. This one here, where it says 6 plus 2 PCI and 4 plus 4 CPU. So now I've got most of the motherboard connected up, etc. The next thing we need to start considering is the graphics card. So this is a Sapphire Pulse 574GB ITX. So this is just the one fan. These are really good cards. They run a little bit hotter than the Pulses, the standard Pulses. Obviously these have got 2 fans, but these GPUs, the Pulses, the standard Pulses run really cool. So these run a little bit warmer. It's still considerably cooler compared to like the Gigabyte 480 card, which runs super duper hot. Here's one of the risers, standard riser. Yeah. PCIe, which you can't see very well. PCIe to SATA power. Connect this into here, like that, and then connect the SATA power into one of these, which you get with your power unit, and then the other end will be a 6-pin sort of power. You plug that into your power unit and you've got a powered riser. What I would say to avoid trying to do is filling up every single SATA port, power SATA, with a riser. You could do, maybe it wouldn't cause any issues, but I try and limit the amount of throughput of power, particularly for risers, because there are no real proper official reputable riser companies. They tend to burn out pretty easily. In fact, 9 times out of 10, if you're troubling an issue that you can't figure out with your rig, it's generally the hardware, i.e. it's generally a riser problem. So yeah, I'll connect all this up and then show you what I've done. So these just simply connect to the bottom of these. Just clip that out, rest that in there, it slots in just nicely. And then if you want to, you can press the clip on the back of the riser, the white clip, and that just secures it nicely. But the risers will be hovering anyway on this particular build. So obviously this is the riser. Basically you get a USB. Plugs into the riser like so. We've got the power. Power's connected to SATA power, which is obviously connected to the power unit as discussed before. This end of the riser, which again is just USB, into this here port. What I'm going to do is I'm actually going to connect it to the first 16 times port, rather than the actual first port of the board altogether. Don't think it matters too much, but it's just the way I like to do things. Obviously, what we'll then do is, because this is the first card that's going in, we would plug that into the first port there, and then second card into the second port, third GPU card into the third port, etc, etc. So what I'm going to do now is I'm going to bring a screen down, connect a screen up, and actually just boot the computer to see if it works. I have decided to use my television as a monitor. So all I did was plug the HDMI into the front of this Sapphire ITX. I plugged that into the telly. I'm going to assume you know how to plug a HDMI in. So the on and off switch is basically just that. You get a little clicky, and you plug these into the motherboard, and it just basically shorts the motherboard into turn it on. You can actually do it via like a paperclip. I have done that in the past, but it's not advisable. Alright, so I just plug them in and turn it on. That is a good sign, because that means that obviously the computer's posted first time, which means the CPU's in right, RAM's in right, and the graphics card, because obviously we're displaying graphics, so we're basically good to go. Next would be setting up a pen drive with Simple Miner on, booting up to that and seeing how we go from there, and then adding the last of the graphics cards, connecting them all up, and then we're pretty much ready to go. Okay, so next what we're going to do is we're going to create a drive, or more specifically a pen drive with an OS on it. Obviously we're going to use a Linux based OS, so running it from pen drive is okay, but if you want to be running something like Windows, you want to be doing that from either an actual hard drive or a solid state. What we're going to do is just go ahead and select this ISO, which I have downloaded and extracted from a zip file on Simple Miner here, which you can just download here depending on which graphics card you're using. Obviously I'm using the the RX series, so this means I need to download this. Obviously select the drive, in this case it's just this pen drive, and then simply hit flash, click yes to that. And it'll just take a few minutes to do that. Sometimes it can take up to 20 minutes. When it's done, I'll come back and show you how to complete the install. Okay, so as you can see, this has been finished now, which means that we can go ahead and start the configuration process. So what you want to do here is you want to disconnect and reconnect the pen drive that you've just flashed, and that will make the drives appear. Just go ahead and navigate to the drives and open the notepad file in the drive that has the config notepad file. What you're going to want to do there is add your email address. Make sure it says user_email equals and then whatever you're. Then what you want to do is go ahead and save that file and put the pen drive in your rig. So I decided to move away from the telly because I couldn't really see the resolution on that telly screen. It was all too small. It was like a really intense resolution. So I moved to one of my monitors and booted it up with all the cards. Put the pen drive in from the flash we made upstairs of the OS of Simple Miner, and obviously did the config of my email address, which I showed you a minute ago, and yeah, it's all working fine. Obviously I had to make a group in Simple Miner and assign the new rig into that group, but I'd already previously made a group, and Simple Miner can show you how to do that. And all the group is basically is just whatever sort of script you want to mine, whatever coin you want to mine, it's all set up in there, and then you can just throw whatever miners you get, new miners, into that group, and it'll just automatically assign everything. I also changed the settings slightly. I put the memory clock at 2040 megahertz and the core clock at 1125. The reason for that is it's just a very simple overclock, nothing too heavy. Guys, thanks very much for watching. If you've got any questions or any suggestions or anything you think I've done wrong, let me know in the comments. Hopefully you'll like this video. I want to start making more videos. But yeah, it's been a good rig build, and it's pretty decent that the sort of computer posted first time and just came on straight away. So yeah, that was cool. But stay tuned for the next video. I'm going to talk about overclocking more in depth, and I'm going to BIOS mod each card, which is not an exact science. The BIOS modding is, but the the overclocking isn't an exact science, but it's important to know what to look out for and keep an eye on the temperatures, etc. So I'll see you in the next video. Thanks.